In this video, I will be demonstrating and completing the evaluative testing stage of my A-level computer science NEA. As you can see from the user interface, it's a graphing calculator featuring a main graphing calculator area on the right and a side menu on the left where you can input, add and remove equations. For example, I'll add y equals x squared. You can also graph a variety of other equations. So for example, I'll try an exponential equation. So 2 to the power of x minus 1 gives you a nice exponential curve rendered on the graph with the parabola. I can try a slightly more complicated function. So for example, x plus 1 divided by x plus 1 squared. And that gives me a graph which has an asymptote down the middle. And as you can see, if I make some changes here, so say I remove the 1, then the box goes red and the graph disappears because I have now inputted an invalid expression. This can be for a variety of reasons, so maybe a missing bracket or a unsupported character, so a dot, or a semicolon. So a dot actually works because it's a decimal point, but a semicolon will produce an error. And once again, missing bracket produce an error, but if I put the bracket back, it will display again correctly. So as you can see, each line has a different color as I add it, and this happens sequentially. So if I keep on adding new formulas here, they will eventually start repeating in colors. So when I do add a new graph, for example, x squared minus 1, the first thing that happens here, the spaces are removed, and I can add as many spaces as I like, and no matter how many I add, they're all removed. And this is part of the input sanitization. Then it will build a tree, and that tree is then used to calculate the values for each vertice. So as you can see, the vertices are rendered as I move the screen, and that happens when I zoom in, zoom out, and this is actually rendering vertices before they're visible on the screen and then unloading them after they become a certain distance away from the screen. So if I were to input a slightly different equation, x minus 1 plus times x plus 1, this gives me the same result, as most of us will know these two are identical, but this actually builds a different tree, and this tree will execute quicker, but this will produce the same output. So while the program is highly capable, it does have its limitations. For example, you cannot graph an implicit function or a parametric equation. So what this means is I couldn't type in something like y equals xy, and I couldn't change this left-hand side of the equation here to be something else. It has to be only x's on the right-hand side. So y equals 3x works perfectly fine, but if I have y, that does not work. Similarly, there's no parametric functionality, there's no t. Another thing is that you can't have any constants. So if I had y equals ax plus c, then that wouldn't work because it's not allowing me to define constants. In some other graphing calculators, they would maybe come up with a box saying define a, or come up with another sort of formula thing saying a equals, but unfortunately I have not had time to implement that. Lastly, there is no multiple character operators. So that includes things like sin x or log x, and these are all shown as invalid. Moving on to the evaluative testing part of the video. To test the program, I'll be inputting a variety of equations from the test table, which is in the design part of my project, and I'll be seeing how well the program handles them. I'll also be dragging and zooming around occasionally just to make sure that these features are working too. So I'm going to start with 5x plus 1, and that renders correctly. this one also renders correctly. And so does x to the power of 5. X to the power of minus 5 also appears to render correctly. And now I'm just going to clear the equations just to clear up the graph. And let's try x plus 1, x minus 1 to the power of minus 1. So it's testing reciprocals. And this does render correctly. However, the asymptote is not exactly rendered perfectly. So you can see when I zoom out far enough, parts of the asymptote are skipped, and if you zoom in, it sort of looks a bit like a continuous curve, which is not what it is. So this is not ideal, and it has been logged in the bug section. So next is simple ones, x plus 1, x with loads of spaces, plus 1. And these both render correctly. Now we're just trying x plus 1, which also renders correctly. Now some invalid data. So I'll try some brackets, and this functions correctly because it's showing me that it's invalid. One thing that the stakeholders pointed out was that it still does render, it renders a line on the x-axis, which is not really ideal. So that should be removed in future iterations. So I'm just going to try and operate it on its own here. So it's a multiplication sign, and I might as well do a plus sign as well, just to verify that both of these are incorrect. And now I'm just going to try constant. So this should be perfectly valid horizontal line, which is fine. Now I'm going to try an equation with a leading negative. So minus x plus 1 squared. And that renders correctly. So we're going to try the positive version of that, which is also correct. Now I'm going to try obscure a bit. So it's going to start with a minus and a plus. And that renders correctly. These next ones, which have a constant in front of brackets, also render correctly. X plus 1, this is without the spaces, this renders correctly. And then implicit multiplication on the right hand side renders exactly correctly as well. And then we'll try a basic exponential graph, which renders correctly. And now, as I've reached the end of my colors, I'm just going to delete all these lines. So now a negative exponential, which is exponential decay. And that looks exactly correct. I'm going to try a slightly more complicated exponential. However, this is slightly borderline because this should actually be the same as 8 times 3 plus x, which is a straight line. And the renderer actually renders that correctly, even though some people might assume do this bit first and then raise that to the power of 2. But that would only be the case if this was surrounded in brackets. Like that. The next one's 2 to the 2x, which renders correctly. And the one after that is 2 to 2x surrounded in brackets. And that also renders correctly. So some more invalid data, we just have an empty data, which again shows that it's invalid. And then just an opening bracket here, invalid. And then we're just going to have some random operators and brackets mixed together, which is obviously invalid data, just to make sure, and that is invalid, which is correct. Now I'm going to try having two operators after each other. So whether this is accepted depends kind of what calculator you use. Generally, if it's invalid, it's fine, but also this is a correct interpretation that it's 5 plus x. However, if we have 5 plus times x, that clearly makes no sense, but it's showing us 5. So this is a bug, and this is not a correct result. We'll try 5 divide plus times x, which is clearly invalid data. And this produces 5 times x. And it shows a graph, so that's the incorrect graph. So that is, I'll just delete these so you can see more clearly. That is clearly, actually, sorry, it doesn't produce any graph at all. So while it's not showing any graph, it also should be showing that this is invalid. So the next one is 5 plus minus x. So this should just be 5 minus x, and that does produce the correct graph, even though you've got that redundant plus operator in there. And the next one is minus x. So this is a leading negative again, which works perfectly fine. And we've got minus minus x as well. So that's a plus x in disguise as with these redundant negatives. Now we're going to try some more implicit multiplication. So x is invalid. That should be valid. In other graphing calculators, it will show as x squared. So that's another bug, a potential thing to change in the future. X times x, however, does render correctly. And now we'll try a few which don't have the correct bracket formation. So if I open 2 brackets here, and then close that bracket, and then open another bracket, and close that bracket, there's a different number of opening and closing brackets, and that's invalid. Now if I flip around the direction of the brackets, so I have a closing bracket and an opening bracket at the end, that also shows invalid, doesn't recognize that. And similarly, if I open another one, sort of closing it, that's invalid. And now we're going to go on to constants. So as constants aren't implemented yet, it should automatically reject any constants I put in. So ax rejected, x plus a rejected, 2a rejected, x to the power b rejected, b to the power of x rejected, lastly a to the bx is rejected as well. So that's all functioning correctly. So as this calculator didn't support sin x, I thought it would be fun to do a approximation of sin x, which is a very complicated function, and this is just mainly to test how it deals with complicated functions. And it deals with it perfectly fine. As you can see, there's no performance issues when you zoom in and out. Works perfectly fine. Lastly, we're going to try x to the 100, which doesn't render anything at all, which it should render almost vertical lines. There are issues with this calculator rendering vertical lines. So if I render x to the 10, then it renders quite steep lines, but as you zoom out, as the lines get almost vertical, then they disappear. So that is one of the issues with the calculator. So the testing is now complete, and I've created a log of all the bugs, which is in the project write-up. Thank you for watching the video, and goodbye.